Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have completed as a chapter number 2. The name of that chapter is active methylene compound. What do you mean by the active methylene compound and what are the important two compound we have studied in that chapter, how that ethyl acetoacetate as well as DEM is synthesized and how its synthetic application with the help of some of the example we already discussed that chapter. And today what we are going to discuss, today we are going to discuss as a chapter number 3, that is the name of that chapter is rearrangement reactions. And as we know that in the organic chemistry means what? The study of compound that contain carbon compound is known as organic compound. And why carbon atom? Because that carbon atom has one unique property. The name of that unique property is a catenation. Catenation means to form the chain. So that's why. And now in the organic chemistry there are the number of reactions are generally taking place or generally are the type of reactions. Mainly there are nearly 4 or 5 fundamental organic type of reactions. Number 1, suppose as addition reaction, elimination reaction, substitution reaction, redox reaction and the rearrangement reaction. In the rearrangement reaction, it is a different kind of the reaction. There are various aspects of rearrangement reaction. The name itself indicates that there is a rearrangement of atom. Generally we know that the organic compound generally containing as a carbon, along with that hydrogen atom, and some of the compound containing heteroatoms such as oxygen, nitrogen, sulfur and halogens. These are the compound may found in the organic chemistry. So here rearranges the atom or group, and there is a whenever there is a reaction taking place, before the reaction what will be the carbon skeleton or the carbon framework, and after adding the reagent we are getting as a end product or the final product. The carbon skeleton is different or may be changed, or some group or atom are rearranges, and we are getting as a different framework of the carbon atom, or what we can call it as a skeleton of that organic compound. In a general specific manner we can define the definition of the rearrangement reaction, like rearrangement reaction in organic chemistry are those in which an atom or group of atoms, that is functional group, alkyl or aryl, double bond migrate within the molecule or from one molecule to another is known as rearrangement reaction. Let me repeat this specific definition once again. Rearrangement reaction in organic chemistry are those in which an atom or group of atoms, that is a functional group, alkyl or aryl, double bond migrate within the molecule or from one molecule to another is known as rearrangement reaction. Now in the introductory part, the most of the rearrangement reaction involve migration of one atom or functional group from one atom to an adjacent atom called as White-Morey 1-2 shift. For example, let us see here. Here I am showing A and B. These are the two atoms. On A there is a one atom or group which is denoted by M. After the reaction, what is happening? A and B I am writing as it is, but the position of M you can clearly see is a change. So this atom number 1 is atom number 2. This is a M denote is a migrating group or atom or functional group, you can call it. M denotes migrating group or atom, and generally this M group migrate from A atom to as a B atom. You can see in the next figure. Here 1-2 shift, it is known as White-Morey 1-2 shift because the migrating group is shifting from A atom to B atom, and therefore it is known as 1-2 shift. It is also known as 1-2 shift, and that 1-2 shift is known as a White-Morey shift. White-Morey shift, only White-Morey shift, 1-2 shift. And here most of the rearrangement involve migration of one atom or functional group from one atom to an adjacent atom called as White-Morey or 1-2 shift. Here N denotes migrating atom or group. This is the migrating group or atom, M denoted over here. And now A is origin of migration or migration source. This A is called as a origin of migration or you can call it as a migration source. And B we can call it as B is a migration terminus. B is known as a migration terminus. Look at here very cleanly, that is a 1-2 shift or Here in the diagram, M indicate as denotes migrating group or atom. A indicate as the origin of migration or migration source. So U R C source, migration source, and B indicate as a migration terminus. These are the terminologies we are going to use in this chapter frequently. So remember this. The most common migrating atoms and groups are generally this M or H means hydrogen, alkyl or aryl group. Alkyl means any methyl, ethyl, propyl, butyl, hexyl, all are belonging to as alkyl. Aryl means aromatic compound. Aromatic compound may be as a substituted. Aromatic compound is generally termed as a aryl compound. And so this type of the most common migrating atoms or groups are hydrogen, alkyl or aryl, but migration of halogen, oxygen, nitrogen, sulfur is also observed. So, and this type of the reaction are generally termed as a rearrangement reaction. How it is rearranges and we are getting this type of the products. And next point we are going to discuss anisotropic and the catinotropic rearrangement. So what do you mean by the anisotropic and the catinotropic rearrangement? That we are going to discuss some of it in the introductory part. So here anisotropic, aninotropic and catinotropic rearrangements. Catinotropic rearrangements. So remember here, first one is a anisotropic. What do you mean by the anisotropic? In majority of the cases, the migrating group migrate with its bonding pair of electrons from migration source to the migration terminus. In just now we have seen this A, B, and here M is a migrating group, and after the migration we are getting this B, here is a M. What is happening when this M is a migrate from A atom to the B atom? A has adjacent atom is a B. When this M shifted from this position to this position, it is going from A to B. During that process, he shifting along with its bonding pair of electron. This bond is nothing but two electrons involved in it, and therefore this M is shifting, it taking its bonding pair along with it and attached to the B, and at that moment what is happening? The A becomes as a more electron deficient in nature. So that kind of the shifting is generally termed as anisotropic. In majority of the cases, the migrating group migrate with its bonding pair of electron from migration source to the migration terminus. This is the migration terminus. This will be the migration source or origin of the migration. Migration terminus is generally an electron deficient atom like carbon, oxygen, nitrogen, sulfur. Such rearrangement are called anisotropic rearrangement reaction. Catinotropic rearrangement. Now let us talk about the catinotropic rearrangement reaction. Other type of rearrangement in which migration of group or atoms without the bonding pair of electron termed as catinotropic rearrangement. When migration occurs, this M shifted from A to B, as we know that A is a migration origin or migration source, B is a migration terminus. When that M migrating group or atom migrate, it leaving its bonding pair of electron behind on that A, it goes without bonding pair and attached to the beta atom, and that type of the rearrangement is known as catinotropic rearrangement. And now rearrangement reaction are usually named after the scientists who invented them. See here, rearrangement reaction are usually named after the scientists who invented them. Various aspects of rearrangement reactions such as mechanism, stereochemistry, and what kind of the information we are getting from mechanism as well as the stereochemistry involved in it. Mechanism provide us step by step description about the events taking place during the reaction and the driving force behind the steps involved in it. It is a very important information we are getting from mechanism. Mechanism, how the bonds are involved there, how the movement of electron that is nicely represented in the mechanism, step by step description of the events which are taking place during the reaction, how the atoms are going from one atom to another atom, and what kind of the driving force behind the steps involved in it. That kind of the information we are getting from the mechanism. Mechanism is a very important as far as the organic chemistry is concerned. And now the second aspect or the second approach is the stereochemistry. And as we know that stereochemistry, stereo means solid, and it is a branch of chemistry which deals with the study of Orientation of atom in a three-dimensional space is known as stereochemistry. Stereochemical aspect give details about the position of various atoms, different atoms and groups in the molecule before and after the reaction, and their orientation in three-dimensional space, that is nothing but as a configuration. So these are two aspects of this rearrangement reaction. One is the mechanism and second one is the stereochemistry. And next one is a type of reactions. Based on the type of intermediates involved in a different reactions, such as migratory terminus and the migratory source, migratory atom or group, types of mechanism, aromatic or aliphatic substrate, aromatic and aliphatic. We know that in the laboratory there is a one very easy test for determining whether the given organic compound is a aromatic or aliphatic. What you require, you take pinch amount of the substance. If it is a solid in nature, put on a burner. If sooty flame comes, that indicates as a aromatic compound is present. If non-sooty flame, that clearly indicates that it is a aliphatic compound. But theoretically, how do you identify whether the given compound is aromatic or the aliphatic? Simple. Theoretically, those organic compound obeys Huckel's rule. That compound are generally termed as aromatic compound. They are very stable, fulfilling the criteria aromaticity. The organic compound should be cyclic. There must be alternative carbon-carbon, double bond, and fully conjugated. These are the certain criteria for aromaticity. Then cation, anion and the radicals involved in it. So rearrangement reactions proceeding through carbocation or electron deficient, or that show major change in carbon skeleton, or a reaction often followed by displacement or substitution or addition or elimination to give or to obtain the stable compound. So number one, rearrangement reaction involving migration to electron deficient atom such as carbon, nitrogen, oxygen, and may depart with bonding pair of electrons, leaving behind an electron deficient atom with sextet of electrons, 6 electrons, and this is followed by migration of an atom or group with its bonding pair of electrons from the adjacent atom to the electron deficient atom, and this is called as 1,2 shift. And migrating groups or atom may be hydrogen, carbon means alkyl or aryl, sometimes nitrogen, oxygen, sulfur or halogen. The migrating group may detach completely from the migratory source, form bond with migratory terminus. Otherwise, it may remain partially bonded to both migratory source and migratory terminus to form a bridge ion intermediate or transition state. Let us see here how it is denoted. For example, suppose we have this, we are talking about here. Let us see here, M denote as a migratory group and L indicate as a leaving group. If leaving group departs completely, suppose let us see first one, leaving group is departs, there is a migration minus Li minus. When leaving group departs from this carbon atom, it taking its bonding pair along with it, and therefore this carbon atom, this carbon center becomes electron deficient in nature, and we will be getting here, I am showing as it is. Then this one, this carbon atom, now this carbon atom has electron deficient nature, and therefore this is called as a carbocation, or we can call it as an open ion over here. And now the migratory group, this migratory group is shifting from here to here, which is known as 1,2 shift, and after shifting or after migration of M from here to here, it taking its bonding pair along with it, and now this carbon atom here facing or experiencing electron deficient in nature. This is a rearranged open ion. The rearranged open ion, rearranged open ion. And now then Nu indicate as a nucleophile. Now this nucleophile is going to attack to the electron deficient, as we know that positive and negative, then and then there is a strong electrostatic force of attraction is there, the driving force to form that bond, and the resulting compound will be obtained. This one, here is a nucleophile is attacking, here M, and this is a totally different nucleophile and M, and we are getting this compound. In the second possibility, this is the first one. Second possibility, when this, I am showing once again here, leaving group, when there is a loss of leaving group, when leaving group detach completely from the substrate, taking its bonding pair with it. It gives over here this one positive charge, and now in the next case what is happening, this migratory group is form as a bond with this. So here is a, now here B is, M is migrating from here to here, there is a departure, and we are getting here this type of the compound. Here M form as a bridge over here, that is the bridged ion, form as a bridged ion, BRIDG, bridged ion, this one. And then there will be a attack of nucleophile, from here, and it get open, so you will get the same product here. I am showing here, nucleophile is here, then this M atom and this. So there are these two possibilities are generally occur in this rearrangement reaction. There is an atom or group or itself rearranging. What kind of the driving force behind it, and how formation of transition state or a bridged ion intermediate is observed in case of molecule in which the migrating atom or group has a non-bonding pair of electrons on heteroatom like oxygen, nitrogen, sulfur, etc. or etc. The lone pair of electrons on a heteroatom is used for a nucleophilic attach onto migratory terminus, and to give the necessary push for the leaving group to departs. The leaving group departs with bonding pair of electrons, and this is called enantiomeric assistance, or commonly known as neighboring group participation. In short, we can say NGP. And I think with this we have seen some of the introductory part about the rearrangement reaction. In our upcoming lecture, we will discuss about rearrangement involving migration to the electron deficient carbon, means the rearrangement reaction proceeding through carbocation, that kind of the various or the different rearrangement reaction we are going to discuss in our next lecture. Till then, have a nice day. Thank you.